So we have this beautiful triangle drawn by yours truly, and we want to come up with the exact values of our 6 trigonometric functions just from the information that we're given. All we know is that this is a 90-degree triangle, our side opposite our angle is 4, and our side adjacent our angle is 6. So the first thing I'm going to do is I'm going to solve for the hypotenuse using handy-dandy Pythagorean theorem. A squared plus b squared equals c squared. Hopefully you've got the hang of this by now, you went through high school, but just in case, this guy is the one you want to remember. So we've got 4 squared plus 6 squared equals c squared, so that'll be 16 plus 36, so that's 52. So the square root of 52, let's see, 52 is 4 times 13, so we're going to say that c is 2 times the square root of 13, which is not a pretty number, but we can deal with it. So now the big thing we have to remember is our best friend, SOHCAHTOA. Remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So, sine opposite over hypotenuse, we're going to have, let me use a different color. So our sine is going to be the opposite, which is 4, over the hypotenuse, which is 2 times the square root of 13. But I'm going to rationalize that denominator, very important. So we're going to have 4 times the square root of 13 over 2 times 13. But this will cancel out, and this will leave me with a 2 up top, so we're going to have 2 times the square root of 13 over 13. Now our cosine is going to be adjacent over hypotenuse, so we're going to have 6 over 2 times the square root of 13. I'm just going to go ahead and simplify this now, so we're going to have 3 over the square root of 13, and then we have to rationalize the denominator, so we're going to have 3 times the square root of 13 over 13. Now our tangent is opposite over hypotenuse, or I'm sorry, it's opposite over adjacent. So it's 4 over 6, which we can just simplify to be 2/3. Now, when we're trying to figure out secant, cosecant, and cotangent, there's 2 different ways you can go about it. You can either just do the inverse of sine, cosine, tangent, or you can do the inverse of your SOHCAHTOA. So you can say that cosecant would be hypotenuse over opposite. Or you can say that secant would be hypotenuse over adjacent, just like cotangent would be adjacent over opposite. When I was first starting out, I stuck with just doing the inverse. So I would do 13 over 2 root 13 for cosecant. That's the inverse of sine. But since we're dealing with a square root here, and that square root is in the hypotenuse, it might be better to do the opposite of SOHCAHTOA. So let's look at cosecant, which is the opposite of sine. By the way, if you are having trouble remembering which cosecant of secant goes with either sine or cosine, what I always do is look at the c's and the s's. So in my mind, I think there has to be 2 c's and there has to be 2 s's. So we've got 2 c's, but only 1 s here. So if I added another c, that would be 3, so we don't want to do that. But here we just have to add an s, so we've got 2 c's, 2 s's, we're good. And then if I look at secant, I've got an s and a c, so I need 1 more of each, so I've got an s and a c there. If I just confused you, ignore me, but that's how I've always remembered. So cosecant is the opposite of sine. So I'm going to do hypotenuse over opposite, so that's going to be 2 root 13 over 4, and then this will cancel out to be a 2, so our cosecant is just root 13 over 2. And like I said, you can flip this guy upside down and re-rationalize the denominator if you want. It just seems like less work to me to do it this way. Now, secant is the opposite of, of cosine, so we're going to have 2 root 13 over our adjacent, which is 6, so it's going to cancel out, it's going to be a 3, so we're going to have root 13 over 3. And finally, our cotangent is going to be adjacent over opposite, so that's just going to be 3 over 2. So there we go, we have completely found the exact measurements for these trigonometric values. Those, I just strung together a bunch of words. But the reason that we make the point and say that these need to be exact values is because we're keeping these roots in here and we're keeping these fractions, and we don't want decimal answers because in trig there are never-ending decimals. It gets very messy if you are dividing things and getting decimals and rounding while you're still doing your computations. It's going to get really messy. Your answer might end up getting really messed up. So when in doubt, always stick with those roots, always stick with those fractions.